Hello everyone and welcome to today's webinar. My name is Susanna Yeti and I'm the AGC Portfolio Marketing Manager and PCB's organizer for this session. As always, I'm delighted to have you all here with us. Before we start, I would like to inform you that PCB is organizing a PCB Certified Advanced Audit Techniques event, which will take place in Stockholm, Sweden from June 27 to July 1st. For more information, visit our website. As for today's webinar, we will discuss the effectiveness of the Hazard and Operability Study methodology in process hazard analysis. To tell us more about it, joining us is Mr. Jacob McLean, PCB Certified Trainer and Principal Consultant and Managing Director of Kaizen Training Management Consultants Limited. During the presentation, feel free to write your questions and comments in the question box in the right-hand control panel, or you can use the raise hand function. We will then unmute you and you will have a chance to ask the question directly to Mr. McLean. All of the other questions will be answered accordingly at the end of the presentation. Also, if you are aware of a topic that you would like to discuss and participants would benefit from, please feel free to write down your suggestions in the survey at the end of the webinar. We are strongly committed to providing our audience with updated and useful information. Please, Mr. McLean, you may start the presentation.
Good morning, good afternoon, wherever you are in the world. Welcome to this webinar. As you heard, my name is Jacob McLean and I'm your presenter today. The topic you heard, the effectiveness of the hazard and operability study approach in process hazard analysis. The purpose of this presentation is to create awareness of the use of the HAZOP methodology in process hazard analysis, to create understanding of the HAZOP process, and to demonstrate the effectiveness of HAZOP as a key safety risk assessment technique. I'm going to share with you a little bit on a case study. This case study involves an actual HAZOP assessment that I was involved in. It was done using the HAZOP software produced by Reliability Software, and it's called HAZOP Plus. I found it to be very effective in carrying through this particular study. The objective of process hazard analysis, or PHA, is to provide guidance towards best practice that will ensure continual improvement in plant safety. It enables the identification of existing hazards in operations, as well as it enables the participants to foresee potential hazards. So it is done on operating systems in organizations that are actually in operation, or it can be focused on the design for a complex organization, typically organizations that are involved in producing chemicals, heavy industrial chemicals, petroleum processing plants, bauxite and alumina plants, and such like. PHA enables the assessment of the on-site and off-site risks to people, property, and the environment. Allows the users to identify risk reduction or mitigation measures as required in the form of recommendations detailing what needs to be done, when, by whom, and how, in order to reduce risks to as low as reasonably practicable. It also enables the participants to prepare a concise and clear report of the risk assessment and the results. There are various approaches to process hazard analysis. As we will see in a little while, the HAZOP methodology is what I use in this particular case. Process safety management refers to a regulation issued by the United States Occupational Health and Safety Administration, OSHA. It involves managers, employees, and contract workers, and it aims to minimize uncontrolled change from design and or operating intent at a facility that could introduce risks that could result in process-related injuries and incidents. So that's within the context that we looked at process hazard analysis. It's a part of the broad spectrum of process safety management. It's one element, in fact. So the elements of process safety management include what you're seeing there on the screen: employee participation, process safety information, and 13 elements. But we focused on process hazard analysis. So process hazard analysis consists of a number of factors, and it aims to identify hazards and provide preliminary estimates of the severity of those hazards. In fact, it's a risk assessment methodology. So we identify the hazards, we look at their potential severity, we look at the likelihood, and we determine the risk related. To identify mitigation, so we not only identify the hazards and the risks they pose, we look at the mitigation measures or the control measures as well. Originally, it was conducted on facilities that were still in the design stage, but its usefulness in operating facilities has been determined, and it is therefore used as a risk assessment methodology at various stages. It's now used increasingly in analyzing operating facilities, so that's PHA used in ongoing operations, not just at the design stage. It enables the identification of hazards, and these are addressed in order to ensure that they are properly controlled. The PHA methodologies are several. There's the what if, the checklist, the what if checklist combination, and of course hazard and operability studies. We also use failure mode and effect analysis, FMEA, or the fault tree analysis. So let's focus on HAZOP, the methodology that I used in this particular study. HAZOP is a study that is quite detailed in nature. It looks at hazards and operability. So as the name suggests, the name is actually an acronym combining both words, hazard and operability. HAZOP deals with the identification of potential deviations from the design intent. What did the designer or the team of designers have in mind? What are possible deviations? If these deviations were to occur, what would result? What hazards would be posed? What risks? To those working at the facility, to the environment, and of course, to persons external to the particular facility. The methodology aims at identifying hazards and problems that can cause catastrophic events or incidents, both with respect to health and safety and the operability of the operations. The methodology was originally developed by the MOND division of Imperial Chemical Industries in the 60s. It is the preferred methods of identifying hazards in new or existing plants in the process industry. So in the oil industry, in the chemical industry, this is the methodology that is used most often. It allows a team of people to think systematically of all possible deviations that might occur in order to reduce the chance of missing something. And I must say that a key requirement in HAZOP is the development and availability of piping and instrument diagrams for the facility that is being considered, whether it is existing or it is a proposed facility that is at the design stage. The design intent is depicted in the piping and instrument diagram, and this forms the basis of the analysis. In order to prepare for the HAZOP study, I took the team through a presentation that would develop understanding of the process. And I used the International Electro-Technical Commission IEC Standard 6188 as a basis for this training. I'm going to go through the method, basically the method that we used, that we highlighted during the training. So we talked about the fact that HAZOP describes the principles and procedures of the standard, describe the principles and procedures of hazard and operability studies. And we talked about what the process entails. So HAZOP is a structured and systematic technique for examining a defined system with the objective of identifying potential hazards, identifying potential operability problems. We talked about how the examination is done. A characteristic feature of the study is the actual examination. And here we actually assembling a team. So I was the team leader, and we had persons from the facility, engineers, operators, production personnel, people from the laboratory, and of course we had the leader, the manager for the facility, who was involved in every session. The study, in fact, took approximately 6 weeks. Of course, it was not a continuous study. We took breaks, so over 6 weeks we had several sessions, sometimes 2 sessions per week, and because we had to pull people from operations, it was not possible to focus on the study on a continual basis. The need for pulling people is sometimes a downside if you're dealing with an existing facility. So the study identifies deviation from the system design intent, and we use a set of guide words, and I will speak to these in a little while. These guide words are used to consider possibilities, what could go wrong. The technique aims to stimulate the participants' imagination. So we use people who are knowledgeable about the system so that they can identify possible deviations that could occur. So HAZOP is an enhancement of sound design using experience-based approaches, such as codes of practice, rather than substitute for such approaches. Some definitions. Characteristic. This is a qualitative or quantitative property of an element. Examples of characteristics are pressure, temperature, voltage. The design intent. What the designer had in mind, the desired design. This is specified in the design intent that is produced and documented. A deviation simply means a departure from the design intent. An element is a constituent part which serves to identify the part's essential features. So it's necessary that those participating understand the various components. So this is why we would take them through definitions. Guide word, a word or phrase which expresses and defines a specific type of deviation from an element's design intent. Harm, physical injury or damage to the health of people, or damage to property or the environment. And a hazard, anything with the potential to cause harm, so it's a source of harm. Part is simply a section of the system which is a subject of immediate study. Sometimes we refer to a node which is depicted on the piping and instrument diagram. A part may be physical, example hardware, or logical, a step in an operational sequence. Risk, and this is a combination of the probability of occurrence of harm and the severity of that harm. We principally think about likelihood and consequence. Key features of the HAZOP examination. It is a systematic approach. So we use the guide words to identify potential deviations from design, and we go throughout the process from beginning to end. We look at various nodes, and we consider how to get the information from the people involved. So we need to take it into consideration that the component of the team, the members of the team are key. We must use experienced people, knowledgeable people. The whole saying GIGO, garbage in, garbage out, is applicable here. We must have persons who are knowledgeable. We aim to stimulate the team members to envisage how the deviation might occur and what might be the consequences. The study leader ensures comprehensive coverage of the system using logical, analytical thinking. And this was my role. We also had a recorder or secretary who manipulated the software and inputted the various responses in terms of hazards, likelihood, consequences. We would look at the pass in terms of frequency in order to arrive at the risks posed by various parts and elements of the system. The HAZOP examination relies on the specialists from the various disciplines, as I indicated. So we must use appropriate skills. So production, engineering, quality, design. We usually do not want the designer present in these studies because there is an inevitable bias. But of course, the designer must be available for consultation as required. The key features involve carrying out the study in a climate of positivity, positive thinking, frank discussion. Nothing should be held back. Records of identified problems must be kept. And of course, we look keenly at possibilities, and we at the same time identify who might be best to resolve these issues. So we do assignment of responsibility for mitigation as we go through the study. So here's a pictorial view of the steps. So first we define the scope and the objective. We define the responsibility. We select the team. In preparation, we plan the study. Over what time? Who will be involved? What days of the week? How will it be scheduled? At what time of the day? We collect the data. We agree on the style of recording. Is it going to be electronic recording? Are we going to use a software? Are we going to use a spreadsheet? How are we going to do it? The estimate of the time is important. Arranging of the schedule. The actual examination involves dividing the system into parts. So here we determine where we're going to start. We're going to start at the outset. Let's say we're looking at a petrochemical plant, or for instance, a fuel alcohol plant. We would look at it, let's say it's coming from overseas, arrival at the port. How is it stored? The tank farm. We look at the pipelines. We look at the boiler that produces the steam that would be involved in the dehydration process. We look at all necessary parts of the system. We ensure that we look at deviation, so we determine what the guide words are going to be. Those are identified up front and agreed. We look at the consequences and causes. We identify whether a significant problem exists, and this is during the examination. So some problems may not be significant, but they are noted nevertheless. We identify protection, detection, and indicating mechanisms. What is there in place? Are there instrumentation that would give us knowledge? Is there a control system in place? We identify possible remedial or mitigation measures. This is sometimes optional, but it is good practice to do it whilst conducting the study. We repeat this process for each element and each part of the system. Documentation. This is vital. So the record of the examination must be kept. It must be thorough. At the end of this study, the documentation must be signed off. So typically the leader must produce a report which would be in draft. This report is sent to the plant site, to the various persons who were involved. They would comment and give feedback, and then the final report would be given. So the report in my study gave details of the study that was done. We in fact captured the results as we went along in the software, and we were able to produce a report in short order. Sometimes a restudy of the parts may be necessary depending on the findings and the criticality. Final report is sent to the client, and that is used to inform actions that are taken. So the basis of HAZOP is a guide word, examination of guide words, applying them to the system. it is in a deliberate search for possible deviation from the design intent. We understand that the system is divided into parts in such a way that it can be systematically and logically examined. The principles, more on the principles. So we look at the elements. The element may be discrete steps or stages in the procedure. It could be individual signals and items of equipment in the control system, or it could be equipment or components in a process or electronic system. Likewise, elements can often be identified further as characteristics, which can be either qualitative or quantitative. The HAZOP team examines each element, and time is spent based on the importance or criticality, and we examine for deviation from the design intent, which can lead to the undesirable consequence. The identification of deviation from the design intent is achieved through a questioning process. This questioning process involves the use of the guide words. The guide words stimulate the thinking, the imaginative thinking, what could happen, and wild and wacky ideas are welcome. So it may sound within the realms of impossibility, but nevertheless, it is considered. Here are some guide words. So we look at, for instance, no or not. That means complete negation of the design intent. It doesn't happen as designed at all. Complete departure. More. This is a quantitative increase. So more flow. For instance, less. Quantitative decrease. Less flow. As well as, this is a combination. Qualitative modification. So we have water and steam as an example. Part of qualitative modification or decrease. So we do not have here the full volume expected. Reverse. So reverse flow. This can be serious. Other than a complete substitution. So instead of water, steam, or some chemical. These are guide words that will be used and applied to each element, each part of the system, systematically, logically, in order to arrive at possible deviation. The design representation. This is a descriptive model of the system, adequately describing the system or a study, its parts and elements, and identifying the characteristics. As mentioned earlier, a piping and instrument diagram is a key in this area. The design representation is typically a PNID, and along with various notations and the design document itself. In doing this study, we set up the room in such a way that we're able to project the PNIDs on the screen, on one screen, and at the same time we have the software up on another screen. And as we went through the various nodes, the various elements of the system, we were able to ask the required questions and at the same time note the possible deviation as we went along. The representation must be the physical design, the logical design. It should be clear what is represented. An accurate and complete design representation of the system on the study is a necessary prerequisite for the examination. The representation should convey the system function of each part, an element, in a qualitative or quantitative manner. It should also describe the interactions of a system with other systems, with its operator, user, and possibly with the environment. So here we want to ensure that the full possibilities are looked at, and the design intent or the description of the system should depict this. The conformance of elements or characteristics of their design intent determines the correctness of operations and in some cases the safety of the system. So what we're seeing here, what is depicted should represent what is going to be built or what is actually on the ground. The study can only be valid if we're looking at what is going to be built or what is actually already built. So this is so critical. A little bit more on design representation. The representation of the system consists of two basic parts: the system requirements, a physical and or logical description of the system. The value of a HAZOP study depends on the completeness, accuracy, and adequacy of the design representation, including the design intent. This cannot be overemphasized. The design requirement consists of qualitative and quantitative requirement which the system has to satisfy and provide the basis for development of system design and intent. Let me move now to the objectives of the HAZOP study. I think you're getting a feel of what it's all about. It's a risk assessment methodology. It is done prior to the actual building of a facility, or it can be done on an existing facility. It's a risk assessment methodology. It is thorough, it is very painstaking, and it can take a long time depending on the complexity of the system we're looking at. The following factors should be considered when defining objectives of the study: the purpose for which the results of the study will be used, the phase of life cycle at which the study is being carried out. Is it the design stage, operation stage? At what stage is it being done? Persons or property that might be at risk. So we look at internally at the staff, the general public, the environment, the system. So a large petrochemical facility located in nearby an urban area would have significant risks, not just to staff, but to persons in close proximity. And of course the environment. If it's located near the marine environment, the sea or some waterway, the risk just escalates. Operability problems, including effects on product quality. So remember, in HAZOP we look not just on hazards related to health and safety, we also look at operability. Are there issues related to maintenance, operation of the system? The HAZOP brings this out. The standard guide of the system, both in terms of safety and operational performance. So HAZOP does that for you. Roles and responsibility. I mentioned earlier that I was the study leader. The study leader is a key person here because he or she determines the atmosphere, must have facilitative skills, must be able to pull out from others. It's rather like brainstorming, being able to direct. This person needs to have some technical skills, so it's not just about facilitating, but must be able to have a pretty good understanding of the system that is being looked at as well. The program of activities should be developed which reflect the milestones of the project to enable any recommendations to be carried out in a timely manner. So if it's a long-term study, let's say 2 years or more, then you're not going to wait until the study is completed before you begin to implement actions. So milestone, as you do phase 1, then actions are taken on and carried out. An appropriate communication system should be set up and used for transferring the result of the HAZOP study. And this is important. So is it going to be by email? Is it going to be face-to-face communication? How is it going to be done? This must be agreed beforehand. I mentioned the documentation earlier, how critical it is. So the strength of HAZOP is that it presents a systematic, disciplined, and documented approach. From the outset, you're looking at what is in place. If you're dealing with an existing operation, so you're looking at the P&IDs, you're looking at the documentation of the system, you're examining it, and you're recording the results of your finding as you go along. If it's a new facility and you're looking at the design, the proposed design, again, documentation is vital. Full recording involves recording all results of applying each guide word. So as you look at flow, no flow, high pressure, low pressure, everything is recorded, all possible deviations. This method provides evidence, so the documentation provides evidence that the study has been thorough and should satisfy the most stringent of audits. It's important because in some jurisdiction, an organization might need to be able to demonstrate due diligence to regulatory authorities that, in fact, they have done a detailed study, a detailed risk analysis. And this method, HAZOP, is key. So the following factors should be considered: regulatory requirements, contractual obligation, company's corporate policy, the needs for traceability and auditability, the magnitude of the risk posed by the system concerned, and of course, the times and resources available. The output from the study details of the identified hazards and operability problems, along with details of any provisions for detection and or mitigation. And typically, we have assignment of responsibility as we go along. Recommendations for further studies, that could be a key output as well. Actions required for addressing the uncertainties discovered during the study. Recommendations for mitigation. The reporting of the results should be prompt, but should not, time should not be a factor in being thorough. So the time specified should be adhered to as much as possible, but the quality of the report should not be compromised. Every hazard and operating problem should be recorded as a separate item. All hazards and operating problems, together with their causes, should be recorded regardless of any protection that may be in place. So yes, there are mitigation measures in place, but it should be recorded nevertheless. Every question raised by the team during the study should be recorded. And of course, the name of the person responsible to answer it. A numbering system should be adopted to ensure that every hazard, operational problem, question, recommendation, etc. is uniquely identified. The study documentation should be archived for retrieval and, when required, reference in the hazard log for the system. There are some significant advantages for HAZOP study. It provides a means for systematically and thoroughly examining the system or process. It involves a multidisciplinary team, and that is key. It focuses on real-life operational problems. So it is not, yes, it is imaginative. However, when we're looking at a system that is in existence, we're talking about real-life problems. HAZOP generates solutions and risk treatment options. And we should note that it is applicable to a wide range of systems. It started out in the petrochemical, the hazardous chemical industry, but it is applicable in many other situations. It allows explicit consideration of the causes and consequences of human error, design flaws, and it provides a written record. So, we are saying that this is a highly recommended approach to identifying hazards and operability problems in major industries. The signing off of the document at the end of the study is important. The team leader, the secretary or recorder, and of course, team members, note should be made of all participants. This is a document that can have serious repercussions from a regulatory point of view and for the functioning of the organization. There may be disagreements. If agreement cannot be reached, the reasons should be recorded. So there may be differences of opinion among team members, and this is sometimes the case. That should be recorded as well. We are basically at the end, and I want to thank you for your participation. I recommend the HAZOP approach. There are many other tools in the toolbox, but this is one that is applicable in organizations that are complex and which face significant and serious hazards and operability issues. Thank you so much.
Mr. Jacob, thank you very much for this presentation. We will go ahead and take some time for questions now. The first question is, What are the common mistakes when conducting an HAZOP and how to avoid them?
Okay, good. Thank you for that question. The approach requires that you have detailed piping and instrument diagrams. Without this, you cannot, and if you're not able to depict this, the system as it exists, then you're going to have problems. So to approach a study without proper documentation is a serious fault. It just will not work. So prior to engaging in the study, if you're dealing with an existing organization, you want to make sure that you engage a professional who can walk your system, your facility, and accurately document what is in existence. So for instance, if you use ammonia, you have a large facility and you use above ammonia at the threshold or above, you need to make sure that you document your piping in an accurate way. You want to document as well interacting systems so that when you're doing a study, you can focus on what is. Another error or downside is to assemble the wrong team. You need to assemble people who are knowledgeable about the system. So people from operations. Another fault is not allocating time. This is a detailed approach. It requires systematic examination, and in an effort to rush through the study, to be able to say, yes, we've done it, you may be tempted to not allocate enough time. But this is important. There are other limitations and issues as well. Because of the detail involved, it may be that people gloss over. That's important. It should not happen. There are some constraints related to the design. If the design scope is faulty, then of course your HAZOP study is going to end up being faulty.
Thank you. The next question is, what competence level is required to lead a HAZOP study?
Okay. It varies. I'm a safety professional, a certified safety professional. I've studied engineering, mechanical engineering, and then other disciplines as well, quality, environment. So I would say the leader should have a broad-based knowledge of the particular, of industry in general, but also we should act within the limits of our professional competence. The person needs to have facilitative skills. So you need somebody who can stimulate thoughts, who can hold a group together and bring them back when they are straying from the point. So leadership skills are vital. So technical as well as leadership skills are vital if you're going to facilitate a HAZOP study.
Thank
you.
There,
of course.
Yes. Yes, continue, please.
Yes, there are, of course, other considerations. You should be available. In other words, your schedule should allow you to do it. In other words, you should not overbook, because sometimes anxiety can be a significant downside, and this will be transferred to the team. So you should prepare to dedicate yourself to the organization where you're leading this particular study.
Thank you. The next question is, how is HAZOP different from risk analysis?
Well, HAZOP is actually a risk analysis technique. So ISO 31010 speaks to various risk analysis techniques, and this HAZOP is just one of them. There is fault tree analysis, failure mode and effect analysis, there's brainstorming, there's cause and effect analysis, Ishikawa diagram, but HAZOP is a methodology that is applied in certain industries. So complex industries, petrochemical, heavy chemicals, this is an analysis technique that is one of choice.
Okay, thank you. And the last question for today, because we are running out of time, is are there any disadvantages of using HAZOP? If yes, can you give us any examples?
Okay, there are some disadvantages, and because of the detailed analysis, it is time consuming and therefore expensive, because you typically want highly qualified professionals involved, and they are not cheap. The detailed analysis requires a high level of documentation or system process procedure specification. This is a limitation. Another limitation is it can focus on finding detailed solutions rather than on challenging the fundamental assumptions. You can get lost in the details. The discussion can be focused on detailed issues of design and not on the wider external issues. What could happen? If there's a rupture, what could happen externally in the environment, in the community, to the people in the plant? You can get lost in the details of the design rather than looking at the wider external issues. It is constrained by the design. So you're looking at the design intent, the scope and objectives related to the design. Now, the design can be flawed, and therefore you may miss possibilities because you're looking at the design intent, and that is a constraint, whereas there are other possibilities that may occur. It relies very heavily, my last point here, it relies very heavily on the expertise of the designers. You may find they may not be available to answer queries, and therefore you may not be able to determine exactly what the design intent is during the examination.
Thank you once again for this presentation, Mr. McLean. It was our honor having you as a presenter. I would also like to thank all the attendees for taking the time out of their busy schedule to join us. We hope you enjoyed this webinar. We received all of your questions, and because the time is limited, we will answer to your questions individually by email. Also, don't forget to check PECB's webinar schedule on our website, pecb.com, and subscribe to our YouTube channel and be updated with our weekly webinars. Next Friday, we will discuss how is ISO 45000 related to ISO 9001. Have a great weekend, everyone. Bye-bye.
Bye-bye.